Hello, we are Team Underdogs, and our problem statement is Comprehensive Automated Document Verification System for Official Documentation, that is SIH 1709. So, what is our proposed solution? We are building a web-based platform that is accessible to the issuing authorities, the verifying authorities, and individuals. Now, who are the issuing authorities? The issuing authorities would be any sort of organizations, for example, any institute, any colleges, or any other sorts of organization who needs to issue some sort of documents to their user base. Who are the verifying authorities? So these organizations would have a linked verifying authority who would be looking after the verification of the documents that has been issued by these issuing authorities. The verifying authorities can also be government agents who would be looking after official government documents, not only the documents issued by the colleges or organizations. Now, who are the individuals? The individuals are we, the normal human beings, the users who would be getting these documents, who would be using these documents to be verified or to be used for any purposes. Now, our platform aims to provide a AI-powered document processing that is using classification, information extraction, and fraud detection. We are using blockchain-based storage for document hashes and metadata. Now, the question is, why are we using blockchain-based storage? The advantage of using a blockchain-based storage or IPFS, that is interplanetary file system, is that whenever a document has been issued by the issuing authorities to any users, these documents get a unique hash of their own, and this hash is stored in the blockchain. What is its advantage? The advantage is that if by any means the issuing authorities or the users, anyone wants to tamper with this data or wants to change any sorts of metadata of this document, then the hash changes, and that would be shown to the verifying authorities who would be able to see that yes, this was the initial hash and this is the current hash, which do not match. That means the document has been tampered in some sort of a way. So this helps in a verification system that is very robust and comprehensive. We are using smart contracts. This project is deployed on Ethereum. So we are using Solidity, that is the smart contract language for Ethereum. We are using Solidity for managing the document lifecycle and access control. So what happens is that if I go to our workflow, as you can see, there is an issuer or the user. So the issuer, they can be organizations, any private company or government authorities. This issuer uploads the document that is being issued to the specified user. What happens basically, whenever the document has been uploaded, this goes through a variety of basic checks for anomaly or spellings or basic signatures. If the checks fail, the issuer would receive a notification that yes, try again later, this is the issue that is being happening. But what if the checks pass? When the checks are passing, this is sent to the verifier. Now the question comes, how will the verifier or the issuer receive these messages? Here comes the most important part of a blockchain, that is wallets. Blockchains have this sort of a blockchain wallet that acts like its unique identity. A user gets their own blockchain wallet. In Ethereum, the most popular wallet is MetaMask. So we are using MetaMask for our platform. So whenever you are using this, whenever you are installing this wallet, you get a wallet address that is unique to your account. This address is encrypted by SHA-256, and this is an encryption method, and this is unique to only your account and no one else's. So we are using this wallet address to send the notifications. So the request is being sent to the verifier by the wallet address. Now the verifier receives the document that yeah, this issuer is issuing this document for this specified user. Now the verifier here runs two types of checks. Normally what happens is that in any sort of a real world scenario, if a verifier is trying to verify a document, they would have to manually check through every single step, that the name, the designation, and everything, if it is correct or not. And it is actually very time consuming and a lot of hectic in the process. So we are using AI verifications here. So the verifier runs many sorts of AI verification, such as Siamese neural network, isolation forest, and also OCRs. So when this verification is being run, then there are two types of tests. Either the tests fail, in that case the notification is being sent to the issuer again that yeah, verifier has been verifying a document and this is the issue and please try again later. But what if the tests pass? When the tests pass, then the verifier would get the notification that yeah, this has been run, this sort of tests has been done, and this is the output. And whenever they receive this, then they can go through it by manually. Yeah, like the test has been very filtered, and this would be very easy for them to go through. So they go through these tests, and when they are passing the test, that is, they are verifying the document. Here comes a part of the blockchain. So till now, the part was of the ML models that would be deployed on cloud using Cloudflare. Now here comes the blockchain part. Whenever the tests are passing, there is this database. We are using PostgreSQL and Prisma for database management and the database itself. And on other side, there is blockchain. That is the IPFS that I mentioned earlier, the interplanetary file system. So whenever the tests are passing, this document is being sent to both of these places. Now in the blockchain, we have a boolean, that is a field that yeah, this is the user, they are being issued this array of documents. What is an array? This is a list of all the documents that would be issued to the user. So yes, this user has this many number of documents, and every document has a field that is the document verified or not. Initially, whenever the issuer is issuing this document, it is being set to false. But when the tests are passing in the blockchain, as you can see here, the document is being uploaded to IPFS, and the metadata, as I mentioned, the hash of this document is being stored in the blockchain. Why? Again, because it is tamper proof. The hash is being stored in the blockchain and it cannot be tampered, because whenever you're tampering it, the hash just changes completely, not even like a single bit. And also the verified form, that is the whatever the document is being verified or not, that changes from false to true. So database, what is happening in the database, that is the database is being updated, updates issued and verified documents status to users database. So this happens together, and this is then being show to the user's account that yeah, you are the user and this document has been issued to you. So this is the entire workflow of our project. Now, as I mentioned in the detailed explanation, all these things. Now, the innovation and uniqueness of our project. There are not many sort of projects in real world scenario who are implementing AI and blockchain in this extent. Now, the question comes is that is our product unique? Yes, this sort of a product where AI is being used for verification purposes and blockchain is being used for storage purposes so that it can be tamper proof, it can be security, like it can be very secure. This sort of solutions are very rare. So yes, synergy of AI and blockchain, that is combining intelligent processing with immutable storage. What is immutable? Immutable is what I mentioned, that is it cannot be tampered. And verification status, multi-stakeholder ecosystem, unified platform for all the parties, that is the issuing authority, the verifying authority, and the individual. Smart contract governance. What is the advantage of smart contract over normal backend server? First of all, it is decentralized. What happens is in decentralization is that the server never goes out. However amount of traffic is there, the server would stay as it is, because it is decentralized, it is peer to peer, there is no central authority or server here. Like in a blockchain, there are multiple blocks that are running together, so even if one of the blocks go down, there are other blocks who are running at the same time, so the server never goes down. Continuous AI powered fraud detection, as I mentioned in the workflow, and user centric data control. Users can grant or revoke access to their documents. So, this is a work in progress. We are implementing zero knowledge to our platform. What zero knowledge does is that suppose the verifying authority has access to this user's wallet address because they were verifying their document. Now, what if the verifying authority wants to like use these documents in any wrong way? So in that case, we are implementing zero knowledge. What happens is zero knowledge proof is that the user would give access to the verifying authority of specific documents of theirs. They are not giving access to every document or every part of a single document. For example, suppose I am verifying to a college that yeah, my JEE, that is a joint entrance examination rank, was less than 10,000 to get a seat in a specific NIT. Now I don't need to show them every detail of my document. What I need to show is only our rank, only my rank. So in this case, I would allow the verifying authority to check only the rank of my joint entrance examination test. This is one of the methods of verification. The other method, as I said, that is the entire process. So we are keeping this as safe for the user and as robust for the issuer or the verifying authority. Now, if I come to a platform, so when we come to a platform, there is a very basic landing page. Now, if we go to the sign up section of our platform, you would be able to see there's issuer, verifier, and user. Now, there are different types of registration process for the issuer, the verifier, and the user. Now, if we go to the issuer page, in the issue section, you'll be able to see that there is an upload new document button. If the upload new document button is clicked, it asks for the user's wallet address, the verifier's wallet address, and the document that is being uploaded or being issued to the user. So I am selecting a Aadhaar card's front side. Now, if I upload the document, it then runs account abstraction and through the backend so that the document is being uploaded and being issued to the user. So now in the verifier section, you can see that there are two documents. One is verified, one is not verified. When I'm running the verification process, it runs the AI verification part, and after some time, you can see that yes, both the documents show verified. Now, if I take you to a database section, you will be able to see that yes, in this documents table, this shows verified. Now, we come to user section. You can see that yes, this user has this document uploaded to their wallet address or their platform. Now, now if you click on view, you will be able to view the document. but there are no options to edit or tamper with the document. And there should not be, because whenever they're tampering with the document, the hash of the data is being tampered and it would then get changed. If I come to our code base, you would be able to see there is a Solidity file. There in the app section we have the website available, and in the ML section there is this certificate.py, that is the Flask server running the ML model that does the signature verification and the general verification in the issuing part. And there is this model API.py file that has the model that checks all the isolation forest, the Siamese neural network, and does the verification part. So this is our entire project, and we are team underdogs. Thank you so much.